In this video, we will learn to find the least common denominator of expressions. To find the least common denominator, 1. Factor each expression in the denominator. 2. Include all unique factors in the least common denominator. When finding the LCD of expressions with the same base, use the expression with the larger exponent. We'll talk about that in the example. So let's find the least common denominator between the denominators 9x cubed and 6x. So let's first factor each expression. Well, 9x cubed and 6x, you can't really factor these because they're not binomials or trinomials. So let's use just what we know to find the least common denominator. The least common denominator is an expression that 9x cubed and 6x can both divide into. So 9x cubed and 6x have to be factors of that expression. For example, between 9 and 6, the least common denominator is 18 because we have to find a number that 9 and 6 can both divide into, that 9 and 6 are both the factors of. Factors mean that it means that 9 and 6 have to both be able to divide 18. And 9 divides 18, 6 divides 18, so between 9 and 6, the LCD is 18. Now, between x cubed and x, even though it's the least common denominator, we're going to pick the greater exponent. We're going to pick x cubed. And the reason is if we had picked the x cubed cannot divide into x. So we have to always go with the larger exponent when we find the LCD. Just like with 9 and 6, we didn't pick a number that's smaller than 9, smaller than 6, because 9 can't go into a number that's smaller than that itself. So with 9 and 6, the LCD was 18, which was bigger than 9 and bigger than 6, because 9 and 6 have to both be able to go into 18. Similarly, with x cubed and x, your least common denominator is going to be x cubed, because x cubed has to be able to go into itself. So when finding the LCD of expressions with the same base, use the expression with the larger exponent. Here's another example. Find the least common denominator. Step 1, factor each expression in the denominator. The first expression can be factored. X squared minus 3x, there's a common factor of x. So we're left with x times x minus 3, and we have 6 over 2x. 2, include all unique factors in the least common denominator. So what are the unique factors? Well, we have an x, we have an x minus 3, we have a 2. Now this x is already part of the LCD, therefore it's no longer a unique factor. Unique factors are factors that don't exist in the LCD. So the first two factors, they have to be in the LCD because the LCD is empty. But once we start filling it in, if you find a factor that's a repeated factor, like this x here, which was already there from the first x, then we no longer have to include it in the LCD. So this will be our LCD. Our unique factors are x, x minus 3, and 2. The second x is already in the LCD. Let's find the least common denominator of x squared minus 25, x squared plus 11x plus 30. So first, let's factor these both. X squared minus 25, this factors into x plus 5, x minus 5, since we have a difference of squares. The x squared plus 11x plus 30, we got to find two numbers that multiply to be 30, add to 11, which are x plus 6 and x plus 5. Okay, so now for the lowest common denominator, we need to find all the unique factors in the denominators. So our unique factors, well, we have x plus 5. That's unique to the LCD because the LCD is empty. X minus 5. Then we have x plus 6 from the second fraction. But the x plus 5, it's already in the LCD. A factor is considered not to be unique if it already exists in the LCD. Because this factor of x plus 5 is already in the LCD, we don't need to include it twice. Therefore, this will be our least common denominator. Okay, in the next example, we have 1 over 6x minus 24, x minus 7 over x squared minus 8x plus 16. First, let's factor each denominator. With 6x minus 24, we can take out a factor of 6, that is the greatest common factor. With x squared minus 8x plus 16, we want to find two numbers that multiply to 16 add to -8, which are going to be x minus 4 and x minus 4. So I'm going to rewrite the second fraction as x minus 4 to the second power. And then the first denominator is still going to stay 6 times the quantity x minus 4. Okay, now the LCD has to include all the unique factors from the denominators. So 6 is going to go in the LCD, the x minus 4 will go in the LCD. All right, now here's what happens when you get to the x minus 4 squared. Remember from our first example, when you have the same base, we always take the higher exponent. In other words, this x minus 4 is in the LCD, but the second one is not. So when you have x minus 4 to the second power, we need to take the base with the higher exponent. So our LCD is going to be 6 times the quantity x minus 4 to the second power.